we have two things going on here with this. One is I mean, the main thing is can we crop sustainably on the space station or another space habitat or a long duration flight if we're going to go really far out there into deep space. No matter what we do, we're going to need fertilizer for the plants. And because we're not going to be able to take soil or anything friable because we'll have FOD, floating orbital debris, or floating object, and that's not a good idea. Aspiration risks and just contamination of instruments and everything else. So we have two choices on Earth, really. We can use anhydrous ammonia, excuse me, which is a really bad day in microgravity. Whenever the astronauts do an EVA and they're working on the ammonia chillers on the space station, they actually have to do what they call a bake out on the porch of the airlock before they can come back in. So they have to sit there and through an orbital day and just literally bake the ammonia off their suits, because the tiniest little bit would release from the suit the minute they came in and float around and is incredibly toxic. So you have dead astronauts. Not a good day. Your other option is the nitrate and nitrites, the chemical fertilizers, which are incredibly energy expensive to produce. And they're also significant in their mass. So when you're paying right now, we're paying just to get into orbit, you know, on this factor of like 50K per kilogram. You know, we can't send very much of the nitrogen-based the chemical fertilizers into orbit. So we really need a biological solution if we're going to do something sustainable. Also, of course, you know, any of the nitrogen additives to the soil, they're going to get used up and they're not going to replenish. So if we're able to use the biological solution, we can get self-replenishing. But we need that the organisms to tolerate the conditions of microgravity. We have a couple of different stressors besides the microgravity on the space station. We have a relatively high ambient temperature, around 30 degrees Celsius or higher. And addition to that, we have very high carbon dioxide levels, easily 5, 6, 10 times what we experience here on Earth. So background on Earth should be around 450 parts per million and slowly climbing, of course. In your classroom, after it's been closed up, by the end of the day, you're probably pushing 900 to 1,000. The Navy limits, I think it's 5,000 parts per million on board a submarine, and it routinely gets over 10,000 on the space station. So it's a tough stress for the astronauts. And so with these two factors, the higher temperatures and the higher carbon dioxide, we also have an analog for what we could end up doing to the planet in terms of climate change, our increasing carbon dioxide backgrounds, as well as the ambient temperatures. So we can really do two things, and stick to the space station's off the Earth for the Earth mission mandate, as well as enabling us to go deeper into space. And then this part 2 of the experiment, which will be flight 7, will be actually flying the cowpea seedlings, with the experimental having been inoculated with the rhizobium, and of course a control that hasn't been inoculated. And you'll be able to run those in your classroom as well.